to CSE 222. Most everyone here was in 224, so I'm going to do an abbreviated version of the intro and stuff. All right, so I am not going to be counting attendance this quarter, but I do have a sign-in sheet just to let me know who's here, and I may pass these around periodically, especially the first week or so, just to sort of see who's coming in. We lost like a quarter of the class somewhere between fall and now. We had like 60 people who passed 224, and we've only got about 45 people in here, so I don't know what happened. And maybe people are signed up, but they're not showing up or something. So if your name's not on that list, write your name on the bottom. But that's the way Canvas looked as of last night, to me at least. All right, so this is CSE 222, Intro to Data Structures in C. And if you don't know me, my name is Nick, so I teach this course. So let me do a quick run through on some of the things in Canvas, but this will be a fairly fast once through, and we're going to try to start getting into some actual data structures today. So it's a course on data structures. We'll talk about what data structures means, since that's going to be the topic for the next 10 weeks. We meet here every day, Monday through Friday. There's two sections, 10 o'clock to 10:50, 11 o'clock to 11:50. You're more or less invited to switch between the two sections as you like, regardless of which one you're signed up for. There's probably going to be space in both sections. I think this one's a little emptier. But if you sleep in, or you have a reason why you want to come to the 11 o'clock one, you can just show up for that one instead. Everything will be more or less synchronized between the two sections. So it's sort of like one big class, just broken into two chunks. I have an open source textbook available online. It's a good reference. Don't read it. It's over 1,000 pages, I believe. Don't print it out unless you really like having big things to carry around. But it's a good reference to just look back on for stuff. But data structures is a subject that has been around for decades. It doesn't change very quickly, so most any text that you find is probably going to work pretty well. Topics to be covered, I'll let you read those because they won't mean a whole lot to you right now. But we're going to talk about different types of data structures, different ways of organizing information inside a computer, and we'll be developing code in C to work with these different types of data structures. Now in 223, we'll sort of use built-in libraries, classes, to give us data structures that we can use for other things, but we're really going to be developing our data structures from the ground up in this course. So it'll give us a really good understanding of what exactly is going on. Course policies are exactly the same as every course you've had with me. Support services, again, if you need some kind of accommodation, a note taker, different testing conditions, low distraction, talk to me, talk to the DSS office, send an email, visit them, something, okay? Accommodations are always available. College-wide policies, again, non-discrimination policy is the same as always. I will let you read it on your own this time, but if anything is going on that's making it difficult for you to concentrate on what you're here for, which in this case is learning data structures, if anything is going on, come and talk to me or talk to somebody, okay? Because Clark takes very seriously the idea that everybody should have an equitable situation in the classroom, okay? Class cancellation. So let me just mention up here, and I'm not going to go into a lot of details today, but as you probably heard, there's a good chance there's going to be a teacher strike starting next week. I'm not going to spend time talking about it right now because a lot can happen before Friday. As of Friday, though, if it looks like this is going to happen, then I'll talk a little bit about what we can expect and what's going to happen. But basically, the class will sort of get paused, and there'll be a period of non-activity, and then after that's resolved, class will continue where it paused. So due dates will be adjusted, and so on and so forth. Okay, so I'm not going to load you up with extra work to do. If teachers are on strike, it'll just kind of be a pause. But of course, you can keep like writing code and working on things during that time. So more about that Friday if it looks like it's going to be an issue. Okay, additional course policies. This is the one that's potentially more interesting. All right, thank you. So if you're coming in late, just go ahead and sign in sometime before the end of class. It's just for my own information. All right, so class meeting times, I told you, my name is Nick Macias. My office hours, you can find them on the ENGRCS schedule website. They're also posted on my door. But basically, it's Monday mornings at 8, Tuesdays at 7:30 to 9, Monday, Wednesday, Friday from 12 to 12:30, and a Friday afternoon at 2. So I got different times throughout the day, different days of the week. Hopefully something in there works. Email is the way to get a hold of me. Do not try to reach me through Canvas email. It will bounce back and say send me regular email. Okay, so nmacias@clark.edu. And my office is 115. It's the other side of the collaboratorium. There's a statue of Einstein standing in the corner. You can see him through the window. So that's my office. So grading for the course, programming assignments, 5 assignments, 20% total. Okay, so that's a fifth of your grade. One-day programs, which we'll talk about shortly, a total of 15%. There's a series of online quizzes. They're all posted on Canvas right now. They're all open. That's a total of 10% of your grade. 20% for the midterm, 25% for the final, and then your service learning project, 10% as usual. Due dates are posted on Canvas. All right, keys to success. I'm not going to harp on this, but I'm going to talk about it up front here. You're supposed to be very proficient in C at this point. Okay, that's what getting out of 224 with a C or better indicates. So you should be comfortable in C. You should be comfortable with programming in general, taking algorithms, converting them into code, things like that. To the degree that you're not quite comfortable with C, right, you're going to need to work a lot to get that comfort level up, because we're going to be using C to learn new concepts. Okay, we're going to be looking at C code and writing C code in order to learn things like linked lists, binary search trees, hashes, heaps, things like that. So C is going to be a tool that we're using, and if you're rusty on C syntax or how to compile code or something like that, you want to work on that like over the next few days and make sure you're up to speed. I'm not counting attendance, but please come to every class, okay? I took attendance the first 4 weeks last quarter, and then I stopped taking attendance, and attendance fell off. And again, and it happens every time, the people who come to class generally get a higher grade in the end. Not because I'm counting attendance, because you learn more when you're in here, when you're actually thinking about the material as I talk about it, and when you're actually asking questions and interacting with it. If I say something in here and you watch the video tonight and then you try to like think about it, that doesn't really work, right? You can't ask questions about it the way you can if I say something and it doesn't make any sense and you can say, I don't understand that, right? So please come to every class as much on time as possible, although if you're coming from the other side of campus, right, you're going to get here a few minutes late. Try to use the class time to learn the material, okay? I'm recording the lectures, I'm posting them through Canvas. You don't need to write down everything that I say. What you do need to do is think about what we're discussing in here. Okay, so when I talk about here's what the malloc statement does and here's how we use it, right, be thinking about that. Okay, so what does this mean? And if something's not clear, that's the time to ask the question. Say, why do we have to do this? Why can't we do this other thing, right? And we'll talk about it. My teaching is not perfect, right? I'm not going to be able to say everything that you need to hear to understand a concept. So when something's not clicking, if you just ask about it right then, we can dig deeper into it. So try to be an active participant in the class. Generally, I suggest avoiding using laptops, tablets, phones, things like that in the class. Once in a while, I see somebody who has a really good system and really good setup where they can actually take notes on a device, and it works. But more often than not, it ends up being a distraction, right? Because computers are really good at like saying, hey, do this thing for me, do that thing for me, hey, go on to a new page, hey, do this, do that, right? And my pencil and paper rarely bark at me and say, hey, would you like to install an update to Pencil 2.0, you know? Once in a while I break the lead, and other than that. And same thing goes with distractions, right? So I talk about lots of stuff, and I intend for the stuff to be interesting, and if I mention something and it's intriguing to you, rather than going and looking it up right then, just make a note somewhere. Like, hey, check out incompleteness theorem, you know, and then look at it later on. Try to stay present in class. All right, do your own work, all right? Don't ever look at another student's code. Don't ever let another student look at your code. Okay, I have had students who are trying to help a friend and shows them their code, and the friend takes a picture on their phone and then types it in and turns it in as their work. And as a teacher, right, my first go-to option there is both students get a 0, right? And possibly both students get kicked out of school. Now, I won't do that, but other places might, right? So even if you're trying to help somebody out and just let them look at your code, right, be aware that somebody can take that code and they can do something with it. Okay, so really, 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 if you're stuck, talk to me, okay? Because I will not give you the code in a way that's going to constitute plagiarism, right? What I will do is try to understand where your confusion is, try to help you understand where your confusion is, and then try to point you in a direction to work through that confusion. Okay, that's a process we want to have taking place. So please, if you're unsure what's going on, right, come and talk to me before you go online and look at Stack Overflow or C for Geeks or something like that. Keep thinking about breaking problems into smaller problems. Okay, this is going to be really critical in this course because the programs you're going to be writing are going to be more complex. You're going to have lots of different parts and pieces. And if you can break it down into smaller and smaller subtasks, right, it'll be easier, it'll be less daunting and more comfortable to do those tasks and put them together. And that's the essence of what you're doing as a programmer down the road. Similarly, get good at writing test code. If your problem is to, implement programming assignment 1, but you've got 10 pieces you have to make to do that, make one piece, test the heck out of it. Right? Write a main program whose only function is to test this one function that you've written, and exercise the heck out of it. This is part of what the ODPs are about, the one-day programs, right? Is about coming up with test code. So that when you've tested your code sufficiently, you can say, this function works. I bless this piece of code. I never have to think about what this does again. I'm just going to use it. And you can be confident that this is like printf or scanf or square root or any other function that you might use. Right? This function reads input and breaks it up at spaces and converts everything to uppercase. Right? So think about testing these pieces as you develop them. Work in Linux. Okay? There's lots of IDEs out there. There's Eclipse, there's Visual Studio, there's code blocks, there's all kinds of things. And people come to the final exam and they can't write a GCC statement to compile a program. Why? Because they never had to do that because they were working in an IDE. And you hit F5 and it compiles your code for you. That's great on the job. That's great when you're being paid to produce working code. It's not great for learning. Okay? Stick with the Unix environment. Stick with the command line. You will definitely end up in better shape, and you're going to be more efficient. Okay, I've never seen anybody use an IDE that's more efficient than somebody using a command line. Mice are not an efficient way to interact with a computer. It's a feedback loop. It's a video game you have to play. Command line, you type, it does. Right? It's a more efficient interaction once you're good at it. All right, so additional policies come to every class again because sometimes I'll say things in the beginning of class. And so if you come in late, at least go back and watch the beginning of the videos. Exams, closed book, open note for double-sided pages of notes allowed. ODPs, I will not accept late. Okay, they've got to be turned in on time. Whatever grade you get, that's the grade that's recorded. There are enough ODPs that if something messes up, if you thought you were doing ODP 210 and you actually did ODP 209, so 209 got a 0, okay, I'm sorry that happened, but that's one grade out of 20 or 30 ODPs for a total of whatever percentage I said that was. So it'll work out in the end. Programming assignments, you can turn in late, but don't. Okay, this is not intended to give you more time to work on it. This is just in case something happens and you don't get it turned in on time, you can turn it in late. 25% off the first day, another 25 the second day, and then no credit after 48 hours. So they do Friday morning at 8. If you turn it in Friday morning at 9, you're down to a 75% max. If you turn it in Saturday morning at 9, you're down to a 50% max. If you don't turn it in by Sunday morning at 8, it's a 0. Okay. You're submitting assignments on Git though. So again, make a Git repository on day 1, the day you start the assignment. Make a Git repo, put me down as a reporter, start pushing your code over. Every time you get to a place where you feel good about your code, like you made some progress, Git push origin master, right? And then, you get a bonk on the head 2 days before the assignment's due. Well, I've got the code that you had at that point, and I can download it and I can look at it, and then you can come to me and say, I wasn't able to get online for 2 days, and we can go from there. But don't wait to make your first submission to GitLab the day before it's due. Okay, we went through this in 224, and I gave you some wiggle room. Okay, I'm not going to give any more wiggle room for 222. Programming style counts. Make sure you're indenting your code. Make sure you're commenting your code. Okay, I'm not going to impose a style on you, but have a style. Okay, your code should be easy for a reasonable person to read, even if they don't know what you did ahead of time. And code defensively, I'm not going to go too crazy on error checking, but low-hanging fruit. If you're asking the user to enter a number and they don't type something in, don't just use a random number instead, right? Make an error message. Do something appropriate. All right, any questions so far? So if we develop code in class and I post it on the server, there'll be a link to it here under shared code. Lecture videos you can get to from here. It's just a YouTube channel, 222 Winter 2020, I think. Some resources. So this is the how-to cheat sheet from 224. Just kind of talks about how to get into the Linux server, right, which is really important. A little bit about how to use Git, and so on and so forth. If you did not take 224 with me, right, go through this and shoot me an email sooner rather than later, and we can sit down and we can go through things like using GitLab to submit assignments and so on and so forth. Link to that additional C book, which I wrote particularly with CSE 222 in mind. So that's a useful reference, and it has some good exercises in there that I feel like people should be pretty comfortable making a stab at. Okay, so if you want to know, am I where I should be with C, right, take a look through there. It's a pretty quick read. I'm going to require you to do make files for your assignments, your long assignments. So there's a video overview of make files if you need a refresher. All right, quizzes. You have one quiz due on Wednesday. This is a Hello World quiz. Let's do a preview of it. What course are you currently sitting in? Okay, so you can work on this at home. This is just to make sure that you have Canvas access, that you know how to get into the quiz site, and that you understand what a deadline is. So you got 2 days to do this. If you want to work with friends on this one, that's okay. And then there's other quizzes, and these aren't due until the end of the month, and then February and March, and we'll talk about these as we go. But the GDB quiz in particular is going to be a good one to work on sooner rather than later, and it's going to give you exercise in using the debugger, and we'll probably spend some class time doing this during class, so we can talk about questions and such. Programming assignments, so PA1 is posted. I will talk about that either the end of today or we'll start it tomorrow because I want to talk about ODPs next. Service learning project, if you did not take 224 and the SLP is new to you, read through this description of SLP proposal for those who haven't started an SLP in some other class. And again, shoot me an email or come and talk to me. Okay, this is a quarter-long project that if you take 223 in spring, you'll continue in spring. So it's a fairly long-term project that you get to pick, turn in a proposal, and then there's a presentation at the end of each quarter. This quarter's presentation will be on March 10th. That's the last Tuesday of the term from 3 to 5. And plan to be there at 3 and stay for the whole 2 hours as usual. If you have an exception to this, send me an email by noon this Friday. Okay? Otherwise, I'm going to expect everybody to be there.
10th of March.
10th of March, last Tuesday of the quarter. All right, and then midterm and final exam. So let's talk about ODPs. So ODPs, remember these are these one-day programming assignments. You write them, you submit them for grading automatically on the server. Okay, you can submit it as many times as you like. And the last grade that you get before the ODP closes, that's the grade that's recorded. So there's a video here, it's about 5 minutes I think, that tells you how to use the automated assessment system. We're going to go through this right now. So let's look at ODP 201. This is a hello world for ODPs. Initial test of automated assessment systems. So your goal here is to write a function named sum that takes 2 integer arguments and returns their sum. Okay, so pretty simple function. Integer sum takes 2 integers. Add the 2 arguments together, return that. Okay, so writing the function is not a huge challenge. It's all this other stuff that's tricky, okay? So you're writing a function needs a main program, right? I'm giving you the main program, but I'm not giving you the source code. I'm giving you this main.o. Okay, it's what's called an object file. It's a compiled main program that if you link it with your sum function, it should do something. Okay? So you write your sum function and you do some testing with it. So let's just play along. So let's make a function called my201.c. All right, so here's a test function I'm going to use. I'm going to call my sum function. I'm going to try to add 12 and 23. I expect that's going to give me x equal to 35. Okay, so let's write my sum function. So there's my sum function. I did spell return weird. And since I'm planning to use sum in my main function, I'm going to prototype it up top. Okay, ODPs, I will look at your source code sometimes if something seems funny, but I'm not grading you on the quality of your source code. So really, if you don't want to indent, if you don't want to put comments, right, that's not going to cost you. But it's really easy to work on your coding style, right? And to do some commenting if you want. Now, commenting on here would be kind of silly because it's a really simple function, but you know. Right, doesn't do any harm. All right, now I got some comments. I feel better. All right, so I'm gonna test this, and I'm not doing anything with assess yet, right? I want to know if my sum function works. Well, you know, it's pretty easy to tell my sum function is probably going to work, but if it's a more complex function, right, you want to check it first before you try to assess it. So I'll compile it, and I'll run it, and it tells me x equals 35. Okay, I think that's probably right. Okay, so I'm going to copy my whole program into this new file called sum.c, and sum.c is just going to be my sum function. Okay, this is the thing that I'm going to feed to the assessment system. So my program is called sum.c. So it says when you're ready to submit your code for testing, do this, gcc-o odp201 / temp main.o and then sum.c. I could call this something other than sum.c. I could call it 201.c or whatever. But this has got to be /temp / main.o. This can be whatever I want, but give it a reasonable name, preferably something with the number of the ODP in it, because I've had cases where students work and work and work for hours and hours and they can't get their ODP to assess correctly, and the reason is that they were naming their program main and they were assessing ODP 201 or something like that, right? So just develop habits, right? All right, so this is saying compile sum.c and link it with this testbed main.o and call the output file ODP 201. All right, so there's ODP 201. It's an executable program. Generally, we don't run this code ourselves. We submit it to the assessment system. If I try to run this myself, I don't know what's going to happen. I'm going to get a seg fault. But that's not a problem because you're not supposed to run this. This is supposed to be run by the assessment system. Okay? This is why you have to write your own main program to test your function first. So I've written my 201.c, I ran it, I'm convinced that my sum function works. I linked it into /temp / main.o. Here's my program I'm ready to assess. How do you assess it? Assess executable program source file. Alright, so now we're running the assessment system. The only command you really care about is G, submit your code for grading. So I'll say G, and it ran 5 tests. I got 10 out of 10 on each. I'm good to go. Okay, hit an X or a Control D to get out of there, and you're done. Now if I do something like this, because I didn't read the instructions carefully and I ignored my comment and I made this thing use doubles instead, right? So I build my test bed and then I assess it and I say grade. Well, I got 0 out of 10 on 4 tests and 10 out of 10 on 1 test. Okay, right now I'm looking at a 10 out of 50. This is the grade that's recorded for me. And 8 o'clock tomorrow morning, if I haven't done anything else, I'm going to have a 10 out of 50. So if we're sure that's not right, and we're like, oh yeah, I guess this should be an int, right? Make sure you recompile and you reassess, and the last time that you assess, you get your 100%. Okay, that's what's recorded right now. Alright, so there's my, we got someone else in there. Alright, so 50 out of 50 versus 10 out of 50. Alright, so everyone good on that? So the assignment will tell you what the function is supposed to do. It will tell you how to compile, how to assess, and then just use the G command to actually run the assessment. So this first ODP is due at 8 o'clock tomorrow morning. Okay, so you want to do this as soon as possible. In general, these ODPs will open at 8 in the morning. So the next ODP will open Wednesday morning at 8. So my suggestion is, if you can, take a look at it after it opens, or right before class, so that in class you can ask questions about it. Okay, it opens at 8, you come to class at 10 o'clock, you can ask questions, and you still got 22 hours to do the ODP. Okay, as opposed to you go home and 11 o'clock at night you start looking at the ODP and you don't know how to do it, or you try it and you're not getting full points, and now you've got 9 hours in the middle of the night to try to get help. Okay, So try to look at the ODP so that you can ask questions about it in class. And we'll usually go over them in class, and I'll show you what we're kind of expecting the function to do. But it's most ideal if you've already made an attempt at it by the time class starts, so that we can talk about issues. And the ODPs are really designed to help you polish your understanding of key concepts, okay? This first batch of ODPs are all related, other than that first one, are all related to programming assignment 1, which is due a week from Friday. So the ODPs will be developing pieces of what you're going to be doing in ODP in PA1. So you really want to understand the ODPs, right? It's not about getting 100% on your ODPs so that your grade improves. It's about using the ODPs to test your understanding and figure out what you need to work more on. Okay, and this is more or less a daily thing. Okay, the ODP I give on Wednesday will either tell you that you understand what you should be understanding, or there's something you don't understand and you should figure it out by Thursday morning. Okay, and then Thursday there's another ODP, and that's something you either understand or you should figure out by Friday morning, and so on. All right, so that's it for kind of the high-level overview, administrative, and the first things that are due. Any questions on any of that? All right, so let's talk about data structures. Which is the point of all of this. So, you know, computers have two things. They have data and code. Code is basically instructions that say do certain things, add this to that, increment this, check this, and so on and so forth. Data is the stuff that things are done to. Okay, data is the object and code is the verb, if you like.
Object-oriented.
What?
Object-oriented?
Yeah, we're getting there. Not yet. So data is key, right, to what we do in computers. And there's this question of how do we store data inside a computer? And I'm not talking about database stuff. I'm not talking about organizing things into tables or being able to make queries. But at a lower level, how do we store data inside a computer? And your computer, you know, has a memory. And memories are still usually kind of byte oriented. So if we just thought about sequential addresses, right, these might be the addresses, and each location stores 8 bits worth of data. Now, our memory doesn't actually start at 0, which is why you get a seg fault if you try to access location 0. But, you know, there's some addresses here, big, long, horrible hexadecimal numbers. And each memory location stores a byte. Okay, so suppose you have a bunch of data you want to store. Suppose I want to store this sign-in sheet. And I want to record a student's name, and I want to record a flag saying, did they sign in on this day or not? Well, I mean, you can just start using the memory of your computer and say, okay, first student, here's the first letter of their name, second letter, third letter, fourth letter, and so on. And I can store their name in the beginning of memory. And then I can store a flag saying, you know, 1, they were signed in, 0, they weren't. And then I can have the next student's name and so on. The thing about data in computers is usually our data is not just a pile of random bits. Right? If it was, we could just throw it all into memory in any old way and just pull it out and use it. But usually when we have a lot of data in a program, there are relationships among the different pieces of data. There's structure to the data. For example, what we might want to do is we might want to have a student's name, and we might want to have the current date, and we might want to have an attendance flag, which might be, you know, a 1 if they were there and a 0 if they weren't. And these 3 pieces of data go together, right? This attendance flag is supposed to correspond to the student whose name is stored here on the date that's stored here. And if I have multiple students, this set of data would be repeated multiple times. And so on. And if I'm careful about how I store my data, I can make my life easier. If I'm not careful, I can make my life harder. So a data structure we learn pretty early in programming is an array. If you have a user who enters 10 numbers, and these are, say, the grades of students on an exam, right? They're not just 10 random numbers. We could call these entries A, B, C, D, E, F, G, H, I, J, right? But that's not terribly convenient when we want to compute their average, because now we need to say average equals A plus B plus C plus D, blah, 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 divided by 10, right? So what we might do instead is make an array called grades, and let's just assume they're integer. And let's suppose we might have up to 100 grades to deal with. So we could make an array called grades, and we could say something like read grades bracket I plus plus, and do that in a loop. Initialize I to 0. And so each time we read a new grade, it gets stored in the next spot in this array. Now these grades are all somehow related to each other. They're all grades on the same exam, perhaps. Or maybe they're multiple grades for one student. But they're somehow related to each other, and I've honored that relationship by storing them in this one structure called an array. In this case, an array named grades. And in memory, this might be grades bracket 0. Well, if my integers were only 8 bits, then this would be grades bracket 1, 2, 3, and so on. But in fact, my integers take 4 bytes, so these all correspond to grades bracket 0. And then grades bracket 1 occupies the next 4 bytes. And grades bracket 2 occupies the next 4 bytes, and so on. And so there's an organization to how this data is stored in memory. And the advantage of this is if I want to know what the 4th grade was that was entered, right, I can just say grades bracket 4 or 3, depending what I mean by 4th, right, and I can access that. Okay, so suppose we want to store names and dates and attendance flags. One thing we could do is we could make 3 arrays. We could make an array of names, an array of dates, and an array of attendance flags. Okay, so this is something we call parallel arrays. And we did this in 224. You've done this in 121, I think. 3 arrays, one for storing names, one for storing dates, one for storing attendance flags. So an array called names, an array called dates, and an array called flags. And the way we set this up is, for example, if I look at names bracket 2, that's a particular name. If I look at flags bracket 2, that's the flag that corresponds to that name on the date given by dates bracket 2. Right? So these things are going together with each other. Right? So this would be name bracket 2, date bracket 2, flags bracket 2. All right, so let's think about names. So name is a set of characters. We know that C is kind of funny about characters, right? In particular, C does not have a type of object called a string. It has characters and it has arrays, and we put those together to make things that we think of as strings, but they're really just character arrays. And part of the problem with that is there's nothing about an array in C that tells us how big that array is. If I say that name is an array of characters, and I give you name, there's nothing there that tells you how many characters are stored in that name. Nothing native to C, at least. Because when I say name, all I'm doing is I'm giving you the address of the first character in the name. That's all you get. And you can start looking at sequential characters after that, and you can get to a point where you see something funny and say, I think that's the end of the name, right? But if there happen to be a bunch of name-like characters stored in memory, you might go through a million characters and say, I guess it could still be part of someone's name. So we have this convention, right? We put this null terminator, this character 0, at the end of our array, and we have this agreement with all of the functions in the string library saying when you get to that null character, that's the end of the string. So suppose we want to store an array of names. Suppose we want to store the names Bob and Mary and Joe. So how can we store these things in memory in a way that lets us get to each of them? There's a few options. One option would be store the first name in the null terminator, store the second name and the null terminator, store the third name and the null terminator. What are some of the problems with storing a bunch of names like this?
Can't easily find, if you said I want to find the third name, you can't really easily.
We can't easily find a particular name. If someone says, I want to know the third name that's stored, all we can do is start at the beginning, look for a null terminator, that's the end of the first name, look for a null terminator, that's the end of the second name, this must be where the third name starts. There's the null terminator, okay, there's the third name, J-O-E. If we have a million names stored, that's really inefficient. We have to go through from the beginning and count. We can do it, right? I've stored my 3 names in there, and all the information I need to pull those out is contained in that organization, but it's not a very efficient way to do it. A slightly better way might be something like this. So here what I'm doing is I'm storing an integer which tells me how long the first name is. And then I follow it with those characters for the first name. And then I have an integer telling me how long the second name is. And then those characters and so on. So now if I want the third name, I don't have to go through every single character. I can leapfrog. I can start here. And I can say, okay, the first name is 3 characters long. I jump down to index 3. The next one is 4 characters long. I jump down to index 7. That's where the third name begins. And I pick off 1, 2, 3 characters. Now if I have a million names, it's still going to take me a million operations to get to the millionth name. But it's not as bad as, doing 7 or 8 million operations going through character by character. But it's still not terribly convenient. So here's a better way to do this. I make an array of 3 integers. And each of these integers is a memory address. And down here in my memory, at location 100, what did I do first? Bob. So that's how my memory is set up still. Just my strings are stored sequentially. But what I've stored in this array is the address where each string begins. So now if I want the third name that I've stored, I simply move to the third element of this array, find that number 109, and starting at that location in memory, there's my third name. And this is very efficient. Because if I know the address where this is stored, and I want the address of the 100th name, I just take 100, multiply it by however many bytes it takes to store one of these addresses. I add it to the address of this first entry. That's the location of the 100th entry. I read that value, go directly to that location in memory, there's my name. So each of these is a pointer to a character. It's a memory address. And this is an array of car stars, which means this whole thing is a pointer to a car star. It's a car star star. That's an argv. Okay, that's what argv is in your main program. It's an array of string addresses. The other thing that's nice about this is suppose I did the following. Suppose that's how my names happen to be stored in memory. My array of pointers could be set up like this. And now my first name is Bob, my second name is Mary, my third name is Joe, which is the order that I wanted, Bob, Mary, Joe, even though the way that these are physically stored in memory is not sequential. And this is going to have a big advantage for us. The fact that our memory can be organized in some way differently from how we want to use it, because we're not going directly to memory, we're actually using these things as pointers. So this is the backbone of what we're going to call a linked list, which is what we're going to talk about tomorrow. And it's what Wednesday's ODP will start in, and it's what PA1 is going to be all about. So we'll start talking about linked lists tomorrow in all their glory. All right, if you came in late, go ahead and sign in. If you're not on the list, add your name to the bottom, please. And I will see you next time.